Okay, so objective 3, we were doing some more practicing with graphing polynomial functions. It started off with a little bit more factoring review, and so same thing as I recommended with objective 2, I would recommend pausing the video, trying that factoring by yourself, that's all here on this first page, and then checking your answers, right? That way you're figuring out, do I actually remember what I learned last year about factoring by grouping? If not, you're either coming in and working with me to get some more practice, or you're emailing me and asking me for whatever it is that you need to make sure you can remember how to factor by grouping. But this video is going to be specifically to give a little bit more practice with factoring. We'll do one together, and then you can pause the video and try it on your own. So if you have not already done the factoring review, stop the video at this point, try these problems on your own, check your answers, then start watching the video when you are ready to kind of do 2 more practice graphing ones. Okay? So, here we go. Graphing. We have some review pieces here from our prior lessons, so reminding ourselves of how leading coefficient and degree impact your graph. So this comes from objective 1. And then some of our graphing techniques, or I guess I should say graphing attributes that we looked at in objective 2. So finding X intercepts, we're looking at like where does Y equal 0, finding Y intercepts is where does X equal 0. And then multiplicity. Multiplicity was how many times our X intercepts occurred. And if we had an odd multiplicity, we passed through the graph. If we had an even multiplicity, we bounced. And so this was objective 1 first, and then objective 2 second. Okay? So we're just doing 2 of these. 1 together, so that way if you needed that kind of quick reminder, you got it. And then 1 that you can pause the video and try it on your own. Although that being said, if you're feeling like you have a pretty good handle on graphing and you'd rather pause the video now and then check both graphs when you have them ready, that might be more advantageous. That way you can still hear the explanation for the part you got stuck on, but you can practice on your own, which gives you a little bit more ownership of the problems. Okay, so again, pause the video when you are ready to try something on your own. And I think that would be my best piece of advice at this point. Okay, so we have our steps over here. This is from objective 2, so it's nothing new. So we're first going to start with factoring. Okay, in this case, we're going to factor by grouping. So in my first term here, we have an x squared in common. And when I pull out that x squared in this pair, I'm left with an x and a positive 5. In the back 2 terms, we have a negative 4 in common. When I pull that out, we're left with an x and a positive 5. And then we've got a GCF here that we can pull out because both the first pair and the second pair have an x plus 5 in common. So when I pull that GCF out, we are left with x squared and negative 4. Which is a difference of 2 squared, so this can factor again. That x plus 5 will hang out, and back here we'll have an x minus 2 and an x plus 2. Okay? So X intercepts and their multiplicity. We have an X intercept at negative 5, at positive 2, and at negative 2, all of which have a multiplicity of 1. And so all of which will be crosses or pass-throughs on my graph. Okay? Y-intercept, where does x equal 0? Or I should say, what happens when x equals 0? Okay, well when x equals 0, we would have 5 times negative 2 times positive 2, which is negative 20. So my y-intercept is at negative 20. Degree, looking at my original function up here, we have a degree of 3. And leading coefficient, looking at my original function here, my degree of 3, leading coefficient is positive 1. And so since I have an odd degree with a positive leading coefficient, I know that my graph is going to be at negative infinity on the left and positive infinity on the right. We do not quite have negative 5 here for my x-intercept, so I'm going to go ahead and scale this. I'm going to count by 2's. Okay, so my first x-intercept is at -5, at 2, and at -2, and all are pass-throughs because they all have odd multiplicity. My y-intercept is at -20, so I'm going to call that -20. And then we have a positive degree, an odd degree with a positive leading coefficient, so we're going to be down here at -infinity on the left. And positive infinity on the right. Okay, so something roughly speaking like that. And in my sketch here, it looks like I drew my minimum at exactly the y axis. I don't actually know that yet. That is something you will eventually learn how to do, is to find that relative minimum. But for now, my sketch happened to kind of look like it's crossing there. I don't actually know, though, that it does without being able to do a further test. Okay? So all this is a sketch, right? Very rough. Okay. Number 2, then go ahead and pause the video, give this one a shot, restart it when you are ready. Or when you're stuck and just want to kind of double check something. Okay, so my function here is f of x minus g of x. So my f of x, -2x to the 4th plus 8x cubed, minus my g of x. So subtracting -2x squared means to add 2x squared. And subtracting 8x, we've got our f of x minus our g of x. Okay, factoring. There is a -2x in common that I can pull out. So we'd be left with x cubed, -4x squared, -x, and +4. Factoring by grouping. In this first pair, we have an x squared in common, which leaves me with x minus 4. Back here, we have a -1 in common, which would leave me with x minus 4. And so now we have a second GCF we can pull out. We already pulled out our GCF of -2x, but now we can also pull out a GCF of x minus 4. And so I'm left with x squared minus 1, which is a difference of 2 squareds. So this gives me a fully factored form of -2x times x minus 4 times x minus 1 times x plus 1. Okay, so we're going to graph x-intercepts. In multiplicity, I have an x-intercept at 0, +4, +1, and -1. All multiplicity of 1, so all crosses or pass-throughs on the graph. We have y-intercept. What happens when x equals 0? Well, when x equals 0, we'd have -2 times 0 times -4 times -1 times +1, which is 0. Okay. We have a degree here. Looking at my function, my highest exponent is 4. And my leading coefficient, the number in front of that highest degree, the number in front of that highest degree is -2. And so with an even degree and a negative leading coefficient, I know my graph is going down to -infinity on both the left and the right. So my x-intercepts are -1, 0, 1, and 4. All pass-throughs. My y-intercept is at 0, 0, already graphed. And then we are -infinity on both the left and the right. So something kind of roughly speaking like this. Probably should come down a little bit earlier. A little bit more so like this. So, roughly like this. Okay. There you go. A little bit more practice with graphing.